So let's see how this sounds. I'm sitting out on my back porch on a beautiful Friday afternoon. The birds are chirping, and my neighbor, of course, has his stupid leaf blower going. So I want to get this lesson done so I can enjoy my weekend. Here we go. When we look at populations, we need to look at their parameters. So, when we conduct a study, the complete set of all subjects that share a common characteristic that is being studied is known as the population. Fancy, fancy, fancy talk for, hey, if I'm going to study how tall people are, then I will get a bunch of people, and they will be called the population. And then I'm going to study the height of that population. So all populations have natural or inter-individual variability. Hey, some people are just taller than others. I can feel you. Most of the time, the entire population is not measured, but we only take a sample so that we can infer characteristics of the population. So all populations have parameters that describe them, and you know these parameters. We've talked about them. Parameters are fancy for, are we going to talk about the mean? Are we going to talk about standard deviation? Are we going to talk about interquartile range? These are all things that you remember from, hopefully, algebra. Maybe the word 5 data statistical study sounds familiar? All right, so let's remember how to use our calculator to get our statistical numbers that we need. So we're going to look at this calculus class, 18 kids, and the results are in ascending order. So the first thing we want to review is, can we do a dot plot? Oh, Tom Brooks is a senior. Let's make sure we say, Tom Brooks, dot plot one more time before he graduates so he can bring back the good old times. When you do your dot plot, you must give me a consistent scale. We can't just throw these numbers down and call it a dot plot. It's got to be on a scale. Because when we look at this, we see something. Wow, we've got all these grades up here, and then we've got this grade down there. Later on, we're going to test to see if that 56 is an outlier. Something we need to just say, that's that kid. If a piece of data is going to throw off what the majority did, we toss it out. We don't look at it. We see that all the time. For example, in house prices. You can't have somebody build a $20 million home in the middle of a community, say like Riverhead, where the average home price is about $750,000. Somebody decides that they want to build a $20 million house up on the Sound and then average that in with everybody's houses in Riverhead. It just doesn't make sense. That's just not a good representation of what the average house goes for. We're going to look at population standard deviation for this data. Now, I have to tell you that when we do box and whiskers, we're not really looking for the standard deviation. The standard deviation comes with a bell curve. There are two different things. There are two different ways to study data. The only reason I'm asking you to do the population standard deviation is we're reviewing. This is back from 8th grade, 9th grade. So the first thing you're going to do is you're going to go to Stat, Edit, and you're going to put all your data in List 1. I've already done that to save time. Once you've entered it, you go back to Stat, and now we get to do some calculations on it. We're going to do one variable statistics. We always do one variable stats. Two variable stats is a no-no. You won't do that. Maybe you'll do it in AP stats, but we're certainly not going to do it in Algebra 2. So now I'm going to press Enter, and it's going to ask me, where'd you put your list? I'm going to tell it in List 1. We don't have a frequency list. That would be if we entered two lists. One list telling me what the data is, and the second list telling me how many of those scores. So for example, up here, you see how there's two 88s? I could have done every number here once, and then in the second list said 1, 1, 2 for 72, 1, 1, 1, 1, 2 for 84, 1, 2 for 88, 1, 1, 1, 1, 2 for 100. I could have done that. All right, we're going to calculate. and up comes our numbers. The population standard deviation is this one right here. Remember, there are two types of deviation. We have sample, and then we have population. It's pretty easy to remember sample was for S, but we don't want sample in this case. Why do we want population? Because we studied all 18 kids. We did not, and I'm going to round to the nearest tenth just because I didn't say where to round. Sample would be something like if we were studying the entire US population. Well, I can't look at every single person. What I have to do is take samples and then make inferences from it. That's what we're getting up to. So just ask yourself, did I survey everybody? Then that's a population deviation. Did I survey some of the people? Well, then that's a sample. The next thing we're going to review is the mean, median, and quartiles for this data. And then we're going to construct a box and whiskers. This is the 5 statistical data summary because there are 5 pieces of data in a box and whiskers. There's the minimum, and then there's the maximum piece of data. And then we take those data and divide them down into quartile 1, the median, and quartile 3. 1, 2, 3, 4, 5. So if I go back to my calculator, notice that's the next thing that it lists. 18 pieces of data with a minimum of 56, a quartile 1 of 75, a median of 84.5, a quartile 3 of 93, and a maximum of 100. So I have my box and whisker conveniently drawn already. Once again, the biggest problem I see with the box and whisker is kids do this. They do a box, they do some whiskers, whoops, and they just randomly draw it. No, you can't do that. You have to have it on a scale. So I can see the spread. I can see how big this box looks. I can see how far away my lowest and my highest is. That's the whole point. So if you see here, get rid of that stuff, my box represents my quartile 1 and my quartile 3. If you remember, quartile 1, as my calculator told me, was at 75, and quartile 3 was at 93. So this is at 75, and this is at 93. So I can see the spread of 50%, half my data. Then this is the lower 25%, and this is the upper 25%. That's what a box and whisker does. The next thing I have to put in, so I've done my quartile 1, I've done my quartile 3, I go and put my minimum in. So I whisker out to my minimum of 56, and I whisker out to my maximum of 100. Finally, I put in my median. When I come back here, my median was 84.5. So I do my best to put my median line right in the middle. So then I know that this is the bottom 50% and this is the top 50%. So my box and whisker breaks it down into, shockingly, quartiles. So I can see where everything is. Now we're going to come back here and talk about this dude who scored a 56. Is he what we call an outlier? Well, I want to change this. This should be actually minimum minus 1.5 times the interquartile range. Well, my interquartile range is simply quartile 3 minus quartile 1, so I have a range of 18 here. That's what that's telling me. So now, my outliers, if they lie 1.5 beyond the max, being quartile 3, I shouldn't really have said max, or if they lie 1.5 below quartile 1, they're outliers. So 1.5 times my interquartile range of 18, it's 18 plus 9 is 27. Now, if I take 27 and add that to 93, because that was my quartile 3, I get 120. So anybody who's 120 and above is an outlier. So now I'm going to do quartile 1, which was, I believe, 75, and I'm going to minus from it 27, because that's what 1.5 my inner quartile range is, and I'm going to get 848. So anybody who's a 48 and below is an outlier. So guess what? This kid who scored a 56 is not an outlier. We can include him in my statistical summary.